Okay, let's jump into this. We're doing a deep dive based on some sources you shared, outlining a really ambitious idea,
Hmm.
integrating AI right across the entire body and white, the BIW tool design process.
Yeah, it's quite something.
I mean, AI involved from the moment customer data lands right through to delivering the finished manufacturing system.
Exactly.
So our job here is to kind of pull out the main idea, the potential impact, and how the process is supposed to work according to this material.
And what really stands out from these sources is the sheer scale.
Yeah.
It's not just automating bits and pieces. It's
Yeah.
pitched as a fully integrated end-to-end thing. The benefits they highlight are pretty big jumps in automation efficiency.
Which means less time, fewer mistakes, presumably.
That's the idea. Less human error. Plus, maybe boosting design quality. The sources suggest AI could even propose, like, new solutions humans might miss. Better tools, maybe.
Interesting. So AI as like a creative assistant almost, not just a faster way to draw.
Sort of, yeah.
Your sources also talk about flexibility, better customization, and this is key, much faster lead times because you're cutting down design loops.
Definitely faster turnaround is a major goal mentioned.
Okay, so walk us through it. How is this AI-driven process actually laid out in the material you sent over, step by step?
Right. Well, it all kicks off when you get the customer's product data. Digital models, CAD files, things like PLPs, principal locating points, weld info.
The raw ingredients.
Exactly. And the very first AI step suggested in your sources is using this data to shingle the parts.
Shingle. What does that mean here?
Think of it like digitally stacking or layering the parts.
Yeah.
In the exact order they'll be put together on the actual assembly line.
Ah, okay.
It gives everyone, you and the customer, a quick visual of how the parts flow together right at the start. Makes it easier to spot potential headaches early.
I see. So visualizing the build order before you even design a tool makes sense. Once that sequence is kind of locked in with the shingling, what's next for the AI?
Then it starts generating some initial process documentation. The sources talk about creating reports that outline operation sequences, what kinds of tools you'll need, estimated cycle times.
Right.
And these reports could be fully automated or maybe more interactive, where the AI drafts something and humans tweak it.
Gotcha. And the actual tooling, the materials seem to focus on weld guns pretty early.
Yeah, that's a key step. Integrating AI with a database, essentially, of known good weld gun designs.
Right.
The AI looks at the weld requirements from the product data, material, joint type, can you reach?
Addressability.
Right. And it intelligently matches the right gun from this library. It considers if it's for a robot or a person, which depends on the setup, costs, location.
Lots of factors.
And then what's interesting is the AI helps configure variations, tips, shanks, arms to get it just right. And because these custom guns often take a while to get.
Long lead items.
Exactly. The sources show the system assigning part numbers and giving dimensions early on to speed up ordering.
Okay, so visualize the flow, document the process, pick and spec out complex bits like weld guns. Then the AI actually starts drafting the preliminary tool designs.
That's the flow described, yes.
Yeah.
Based on all that upfront work, it generates initial tool designs, might even offer a few different concepts.
Variations.
Yeah, initial layouts, how things will be clamped. And this leads to something your sources really stressed. The 20% human review.
Ah, the checkpoints. Tell us about those. Why are they so important in this AI process?
Now, the 20% review is where the human experts, you and the customer, step in. You look at these early concepts. It's that vital sanity check, right? Making sure the AI's general direction makes sense in the real world, aligns with manufacturing know-how. Before you sink tons of time into detailed design, you get feedback, sign off on that stage as documents.
Okay, validate the early direction. Makes sense. What happens after that 20% sign-off?
The concepts head into the robot simulation environment. Your sources specifically mention using standard software, like Deneb, RobCAD.
Familiar tools.
Right. And here, the AI reviews and refines the initial robot paths. It checks for collisions automatically, optimizes cycle times, makes sure the robot isn't overextended.
It's a working envelope.
Exactly. And this is also where ergonomics come in, if humans are working nearby and safety documentation gets generated.
Safety's huge. And payload checking. Is that automated too?
Oh, absolutely.
Yeah.
The AI system is described as calculating the weight of whatever the robot's holding the end-of-arm tooling, the gripper, the gun,
Right.
and checking that against the robot's capacity along the whole path.
Yeah.
If there's a risk of overload, it flags it. Might suggest changing the path or even tweaking the tool design.
Smart. So building the design, checking the robot side, safety, payload. As things get more detailed, what leads up to the next big human check?
As the design gets closer to, say, 50% complete,
Yeah.
the simulation data gets updated. Then comes the next key checkpoint,
Mm.
the 50% design buy-off.
Another sign-off.
Yep. More documentation prepared for a detailed review and signature from the customer. Around now, your sources say controls get added, sensors, switches, and the AI can help draft the initial control logic, maybe even wiring diagrams.
Okay. And what about standard parts you just buy?
Yeah, vendor buy-off for commercial components is mentioned for this phase, making sure specific sensors or whatever will work, giving suppliers a heads up.
Procurement.
Right. And the system generates bills of materials or BOMs, early ones and final ones, listing all these parts to help with purchasing.
Okay, so after all the final details are in, including things like swept volumes for safety zones and the final bombs are set, there's one last human look before it all gets stored?
Correct. The full final designs, the simulation results, updated layouts showing maximum reach, those swept volumes for safety, it all gets presented for a final human review.
Final check.
And once that's reviewed and signed off, your sources say the AI system talks to the PLM software product lifecycle management.
Ah, the data management system.
Right. To automatically check everything in, archive it, version control, secure storage. Then finally, it's on to building the actual system, testing it, and delivery.
So let's wrap this up. What does this all mean? This deep dive into your sources, it really sketches out a vision where AI isn't just doing one task.
No, it's more like an intelligent assistant guiding the whole very complex BIW tool design journey.
From start to finish.
Yeah, and it clearly points to potential big wins in speed, efficiency, maybe even design quality and safety, all enabled by using AI smartly, but keeping humans in the loop at critical points.
Like those 20% and 50% reviews.
Exactly. Those oversight moments are key in the process described.
Which really brings up a big question for you, the listener, to think about. If AI starts handling more of this complex design work, the optimization, the endless documentation, how does the role of the human expert change? What does that partnership unlock in terms of maybe new kinds of innovation or different ways to ensure quality, something for you to mull over?